Hi everyone, today we are going to discuss question 2 of the Mathematics assignment 2. We are given the question of an ad hoc committee consisting of 4 members is chosen from 5 lecturers and 3 students. Find the number of ways the committee is made up of 2 lecturers and 2 students and etc. etc. We are given 5 questions, and first of all, we are going to solve this question by using the combination method. Because the arrangement and positioning of the committee members is not important in this question. So to solve this question, I'm going to draw 4 spaces, or maybe you can call it 4 boxes, for each of the committee members. For question A, we are given the question 2 lecturers and 2 students, so we must fill in 2 lecturers and 2 students into these boxes. So I will put an L to indicate it is the space for lecturer and S for a student. So I'm going to use an easy and effective way to help us solve this problem. First of all, we are going to put in a 5 because we have a total lecturers of 5, and 5 of them are going to compete for this space. So there's 5 possible lecturers to be filled into this space, and then we are going to put in a 4 because one lecturer is already into this space, so we only have left 4 remaining lecturers. And then we multiply by 3, multiply by 2. You know why? Because 3 is the total number of the student, and if we subtract it by 1 minus 1, we got 2 remaining students. So we can simplify this, the whole thing as 5C2, because 5 lecturers competing for 2 space, which is in combination method, multiplied by 3C2, because there are only 2 spaces for 3 students. So hence we got the answer of 30 ways. That's all for the question A. And for question B, not more than 3 lecturers, which by the way means 0 lecturers, 1, 2, or maybe maximum 3 lecturers can be filled into the committee. And hence we are going to do this in another way, because there are multiple possible ways. Still the same, we are going to draw 4 boxes and then put in the multiplying sign between them, and I'm going to put in 1 lecturer and 3 students, because the maximum number of students is 3, and we cannot form a 4-member committee out of the 3 students. So we need to put at least 1 lecturer into the space in order to make sure that the committee members is made up of 4 members. So still the same, 5 lecturers competing for 1 space, and 3, 2, 1, because 3 students competing for 1 space, and then we got the remaining 2, and then the last one. So we can simplify this as 5C1 multiplied by 3C3. And for the other case, we still got the 4 spaces, still got the multiply. We got 5 lecturers competing for 1 space, and then 4, because we're going to put 2 lecturers in this case, because 2 lecturers is still no more than 3, right? So 3 and 2, and can be simplified as 5C2 multiplied by 3C2. And for the last case, which is pretty simple, right? We got 3 lecturers and 1 students. 5 multiplied by 4 multiplied by 3 multiplied by 3. You know why? Because we got 5 lecturers competing for 1 space, and then minus 1, you still got 4 remaining, minus 1, you still got 3 remaining, and then last we're going to put in 1 student, and there are still 3 students remaining, so there's 3 possible students to fit into this space. So we can write it as 5C3 multiplied by 3C1. And to sum up all three of this solution, we are going to write it as 5C1 multiplied by 3C3 plus 5C2 multiplied by 3C2 plus 5C3 multiplied by 3C1. and the total number of ways is 65 ways.
So for second question, it asks us about to have at least one lecturer and one student in question C. So to solve this question, we will have one lecturer and 3 students in the first case, where we have at least one lecturer and one student, and the other space is occupied by 2 other students. And for the next case, which is the second case, we will have 2 lecturer and 2 students, where we have at least one lecturer and one student, and other 2 spaces is occupied by 1 lecturer and 1 student. And for the third case, we will have 3 lecturer and 1 student. The other 2 spaces will occupy by 1 lecturer and 1 student. So we will total up and we will have 65 ways as the answer. So for the next question, which is 2E, it asks us about all lecturers. So to solve this question, we will have 4 all lecturers and 0 students, and we will have 5 ways as the answer.
For the last one is the question require one particular lecturer and one particular student. So from the information given, we will have 5 lecturer and 3 students. So I put, for example, I put my beloved lecturer, Madam Radia. So I put the symbol M, and the beloved students, I put A, which is Ama, and when we total up, we will get 8. Okay. From the information given, 4 members is chosen. So we will have 4 empty space. For the first and second place, we will put Madam Radia and Ama, and it will be multiplied by 6 and 5, which is it's referred to 6C2. So make it simplify. 1C1 multiplied by 1C1 multiplied by 6C2. So the final answer is 15 ways.